All right, we are going to start taking a peek. We're finally through Unit 1. So we're going to take a review over in a couple of pieces over how to do some of the different things we've been working on to make sure that the unit test goes really well for us. So we're going to start with some basic Algebra 1 review. A little distributing there. My next job is to get all my terms, all my x terms to one side. I like keeping my x terms positive, so I'm going to go ahead, subtract that over. Okay, once all my x terms are together, I can go ahead, work on isolating that variable term. So whatever's not in the box, we do the opposite of to get it to the other side, and then I can just divide to finish. Okay, nothing going on too bad. Same idea working in number 2, except we got a few more sign issues to deal with and a little more distributing to do. Make sure that's a -4 that you're distributing to both terms on the left. And on the right, don't lose that minus that's with your x. Now again, some of you may prefer to get all your x's to the left, whatever it may be. My personal preference is to try and keep my x values positive. So I'm going to go ahead and move the -4x. And it's important as you go step by step to try and slow down enough to make sure we don't do something silly. Like I've seen some of you on a problem like this, then add the 12, and then all of a sudden there's not an equation anymore. You don't have the 0 there. So it's much better for our purposes to just take things step by step. Till we get to the end and get our answer. So again, it's about detail work. I got to take my time enough to be able to do a good job with the detail. So I keep working my way down here. I see a proportion. I know I'm going to cross multiply. Now why the parentheses again? Oh yeah, because when I go to cross multiply, I have to multiply that 8 to the x and to the -2. And the 3 to the x and the 6. Otherwise, I tend to forget that. So I'll distribute my 8x, distribute my 3x, and now we're back in the same situation we were on the first couple. Work on getting all of my x terms together. Once I have all those together and I get on a roll, and again, don't be frightened if you get a fraction for an answer sometime. Fractions are part of math, especially in algebra. So if we get those, we do. And then the last one up here, we've actually spoken quite a bit. I think we've talked about this in every review that we've had so far. The idea of finding a common denominator. And we've talked before about how I'd like to get the smallest one that 2, 3, 4, and 6 all go into, which in our case would be 12. But if you don't remember that, don't panic. Your other option would be to multiply these numbers together and use that as your multiply number out here. Yes, the numbers are going to get big, but that's what we have a calculator for. Okay, you'd still get to the same answer at the end. So as I distribute this 12 through, 12 times 5 is 60. Don't forget to divide by your denominator. So 12 times 5 is 60, divided by 3 is 20. 12 times -5, don't lose your sign there, is -60. Divided by 4 is -15. And just keep rolling. 12 times 5 is 60, divided by 6 is 10. 12 times 1 is 12, divided by 2 is 6. Just like that. Looks like the other ones. Not such a bad thing. Do the opposite to get my x's together, since they're on opposite sides of the equals. And once that's done, isolate my variable term. And again, if I get a fraction, that's okay. I'd prefer that you just leave it as a fraction, but if you went to a decimal, I guess I couldn't jump up and down and scream too badly. So then we get back into kind of one of our arch nemesis from before. Okay, solving for expressions, solving for equations. Solve for a. Like a is stuck in the middle of this 3 and t. But what am I doing to the 3a and t right now? I'm multiplying them together. So what's the opposite of multiplying them? Divide. So the pieces I don't want, I'll just divide out. Sometimes it can be just that simple. And I'm set. Now the next one's a little trickier. Okay. B, I can't get to that right away. So I'm going to work with what's furthest away and work my way back. Okay, I want to get this 2x out of there, but right now I'm dividing by 2x. I'm going to times. It's going to look weird, but it's the right thing to do. So 2x times y equals b minus 5a. But again, keep your eye on the prize. The prize is getting b by itself. Well, right now I'm minusing 5a. So I do the opposite. And I'm set. Okay, last one in this section. I take a peek. Ooh, now p. I got to solve for p, but wait a minute. I can't box in p. There's 2 of them. Ooh, that should tell us something. What do these 2 terms have in common? P. I need to factor the p out. P times what is 2p? P times what is negative pt? I already have the p in both cases. Now there's only 1p left for me to work with. And what am I doing with it? I'm multiplying it times the 2 minus t. That's what the parentheses are. What's the opposite of multiplying by something? Dividing by it. Mark those guys. And I'm set and ready to go. So now we'll move on a little bit here into our inequalities. Now there's a couple of things I can notice. One, on this one, I see there's a bracket on 3. So that's automatically going to get rid of the 2 that have a parenthesis on 3. My other thing to help me is that it goes from left to right. Well, left is going to keep going left, 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 left forever to negative infinity. So I want to use a. If it's going to the right, it'd be positive. And then finally, a taxi company charges an initial fee of $10 per ride plus 80 cents per mile. Write an equation that describes the relation between miles, m, talking about our miles here, and cost, c, in dollars. So we've talked before about kind of verbally thinking about this. My cost equals my fee plus my miles that I've driven. So c is going to be the initial fee to get in the taxi, 10 bucks, plus 80 cents per mile. Nothing to solve, just trying to set that up and get that ready to go. Nothing too shabby again. So as we turn over, Jenna is buying plants for her garden. The tray of 12 petunias costs $8 each. A tray of 16 marigolds costs $6 each. Jenna wants to plant a total of $348 and spend a total of $190. Assign your variables. Okay. So let's see. P. Now, let's see here. P is going to stand for petunias. We'll come back to that in a minute. M is going to represent the marigolds. Okay. This time, petunias is going to be the number of trays. I know how much the trays cost, so it's not priced this time. So it's going to be number of trays, and that's going to be the same thing with my marigolds. So when I set up my system of equations, I'm always looking to see, what do I know? Well, I know petunias cost $8 each, And I know marigold trays, cost $6 each. Do I know how much money total I spent? I do. I spent $190. So this is kind of like my money equation. So then I look at the other one and I'm like, okay, so let's see. A tray of 12 petunias, and I have trays of 16 marigolds, and there's 348 flowers total. So you notice I found the things that had something in common and put those together. We don't have to solve this, don't have to get fancy. We're just trying to get that set up in that way. Back to our favorite. It's like 3 days in a row. Okay, factor each completely. Make sure you have your breakdown sheet out and available. You've gotta be sure you're ready to go with this. So, first thing, you know it. Golden rule. Is there anything in common to factor out? If there is, you've got to get all of it, the number and the variable. And then whatever's left over, 6 times what gets to 24? I got 1x, I need to get to 2. 6x to get to 6x, and I'm set. And as I work through these, I just keep asking myself that same question. Anything in common with all 3 terms? Not this time. Nothing in front of x squared. So this is again where I can do a diamond type problem where I'm looking to multiply to get the number on the end, add to get the number in the middle. I look for my clues. Multiply into a negative means I'm going to have one of each because that's the only way I can get a negative answer. So I need 2 numbers that are 1 apart that multiply to get 56. Hopefully you're thinking 7 and 8 right now. Well, which one goes where? Does it matter? It does. Since the negative is my add number, the bigger of the 2 numbers has to be the minus. And I'm set. So then I get to 13. And I go, wait a minute. No, they don't have anything in common, so let's see here. What size is my polynomial? 2 terms. Are they perfect squares? 36, 49. They are. Okay. So, again, how do I do these? Well, what do I square to get my first term? 6x. What do I square to get my second term? 7. And as you notice here, it's 1 plus and 1 minus. Well, why is that? Because the product is negative, and I can only get that by having 1 plus and 1 minus. You see how the sheet can come in handy here a little bit? Just saying. So then I get to 14. I'm like, oh, nothing in common in 3 terms. Nothing in common. Number in front of x, you slide and divide. Oh, yeah. As you remember, you were smart and wrote an example on the back. I hope. Maybe. Slide that 3 on down. When we slide it, it's multiplying to the end. Oops, that's 2x. I've tried to make it 24. That would have been interesting. Again, look for clues. It's a negative multiply number. It means I have 1 sign of each. Positive add number, which means the positive number is going to be bigger. So 2 numbers that multiply to 24 that are 2 apart from each other. 6 and 4. The 6 has got to be the bigger. But be careful, you're not done. This is not called the slide method, it's slide and divide. I've got to divide both of those by 3. If it reduces nicely, that's super. If it doesn't, I make sure it's simplified as far as I can. And then I swing that back to the front. Now I'm done. Okay, when this swings back, it doesn't stay under here, it's literally moving, and then I get that one and I get my answer. And we're going to get to play with one more of these because the next one, nothing all 3 terms have in common. Bummer. More slide and divide practice. 6 times 12 is 72. So again, I go looking for clues. All right. my multiply number is positive, which means they're both positive or they're both negative. Sign in the middle will tell me which. Both negative. So let's see, 72. I need two numbers that add up, since they're the same sign, to 17 multiplied to get 72. Now, if I'm not sure at this point, what I normally would start doing is I'd start dividing small numbers into the calculator until I find a pair that get what I want, which means they have 17. So I get that. And again, if I got to play with the calculator, I do, but it doesn't mean I quit because I don't know what multiplies 72. Okay, we're going to divide by 6, and here's where I've got to be careful. Okay, you're like, well, wait a minute. 8 doesn't, 8 divided by 6 is a decimal. So I just swing that 6 back to the front. Wait. Is your fraction reduced as far as it can go? No. That has to be done before you swing that denominator back to the front. Because otherwise, it doesn't FOIL outright, and I get the wrong answer. Once they're reduced, now I can swing them back to the front and get myself the right answer. And it won't be so bad. Now, some of you may look at 16 and go, oh, I got to do it again. Do I? If I'm paying attention, I don't. Perfect square, perfect square. Whenever I see perfect squares for my first and last terms, I can make this go really fast. What do I square to get my first term? What do I square to get my last term? And what's the sign in the middle? Now notice, let me pull this down a little, that's different from 13. Now those were perfect squares, like why didn't I just use minus? Because for this to be minus, okay, this is the number I'm multiplying to get. If I multiply to get a negative, I have to have one of each. Here I'm adding with the middle number, so I use that same value. All right, last one in this first part of the review, and then we'll wrap up for now, and we'll start up again here a little later. For the expression x squared plus bx plus 15, is there just one value for b? Is there more than one b value that would make a true statement? Justify your answers with examples. You're like, well, what do you mean? Is there a number I could plug in for b that would work for this? So here's what I'm going to ask you. Okay, 15. If you were going to make a list of numbers that multiply to get 15, name me some. Well, 1 and 15 and 3 and 5. Okay, so what I would do is, if I made myself two sets of parentheses and I did x plus 1, x plus 15, and then I FOILed that out, so x squared plus 15x plus 1x plus 15, and I worked this out. Okay, my b value for this one would be 16. Now, is that the only answer I could ever get? Well, I think I'm about to prove that that's not the case. I FOIL this guy out. See, this is some of the in-depth thinking or analysis of this that we need to start doing, because this is what standardized testing is starting to become. And we gotta be ready for that. You're like, okay, I FOILed it out. No, I didn't get the same answer. Is there more than one value for b? Yeah. Here b is 16, here b is 8. Okay, justify your answers with examples. Yes. Is there more than one value? Yes. Okay, we will continue with more of this later to get to the rest of it in part 2, but for now, keep working hard at this and go back and look at some of these lessons again if you need to.